I'm Peggy Peck, MedPage Today. We're here at the RSNA meeting in Chicago, where once again there are thousands of studies, lots of news, lots of interesting research being reported from around the world at what is the largest radiology meeting in the world. And I'm talking about the news today with Dr. Joseph Tashjian of St. Paul, Minnesota, and Dr. Philip Alderson from St. Louis. And we're going to talk a little bit about the two studies reported here today that seem very interesting. One reported a partial breast irradiation in a sort of unusual group of women with early stage breast cancer, a different population. Dr. Tashjian, I wonder if you could talk a little bit about that study.
Yes, what this study reported was using brachytherapy, which is what you do is you take little radioactive seeds and you put them around the area where the tumor was to try and kill any tumor that might be left behind surgery. And the importance of this study was it looked at patients who already had an implant in their breast. So these patients typically like to have a very good cosmetic result, and the advantage of this type of treatment is to really give them a nice cosmetic result, at the same time really give them an excellent clinical survival and kill the tumor in the breast. One of the things that we know when we radiate the entire breast, which is common if somebody has a lumpectomy, is that the implant will develop a contracture. It will become very hard and it won't act like a normal breast and it won't look like a normal breast. And the real advantage of brachytherapy is that you just radiate that one little spot, not the whole implant. And so the whole breast doesn't develop that contracture and really has a very normal appearance. Another real advantage of this type of treatment is it only takes 5 days versus whole breast irradiation, which takes about 6.5 weeks. And because you're only radiating a small part of the breast, you really don't get that fatigue factor that you do when you're radiating the entire breast.
So, Dr. Alderson, this is a small study. Now, it's 70 women, one center, so no randomization in it. No control arm. But the other thing is the follow-up is out to 26 months. Now, tell me a little bit, 26 months on a breast cancer study?
You would, I think, ideally like to have it a bit longer than that, but I think that's a reasonable place to start. And they probably were interested both in the cosmetic results as they were in the survival issues. So you could get a good idea of those at 26 months. But I think they should continue to follow this group a little further to find out more about it.
So in general, we're talking then some early results, interesting, different population, but as I understand, there's a very large trial going on of brachytherapy looking at women. This is a non-augmentation population.
Right, there's a 3,000 study women, or 3,000 people, women undergoing this trial comparing conventional X-ray treatment to the breast versus this brachytherapy to see if they will have a long-term clinical similar result.
And from that large trial, which is an NCI-funded trial, we'll probably get some real answers. Is that correct?
Absolutely.
And this is a controversial area. I mean, radiation oncologists do disagree about whether brachytherapy, local therapy, or external beam therapy is the right way to go in this disease. So I think this is a very important trial.
So, and an answer is needed.
And an answer is needed, that's right.
All right, let's look at another trial reported today. Now, this was an interesting study looking at signals in the brain, messaging in the brain, the way we interpret data in the brain in autism, what that can tell us about autism. And it uses an interesting and fairly new modality, which is magnetoencephalography. I understand there's only 100 of these devices in the world. Tell me a little bit about this finding.
Well, the finding and the device are both interesting. There aren't many of these devices in the world. They're highly sensitive ways to monitor and localize spatially the magnetic signals in the brain when the brain processes information. So they have a great ability they're very fast. So they can really look specifically at where that signal originated. That's considered one of the strengths of MEG, or magnetoencephalography. So in autism, what the people from the Children's Hospital of Philadelphia who presented this work found was that the ability of the autistic children to process a simple auditory signal, a tone, was slower than a set of normal controls. And when the signal became even more complex, two tones in sequence, then they were even slower than the normal controls, suggesting that the autistics have a problem with rapid processing of complex stimuli from the environment. So you can imagine, just extrapolating that idea, how it might be for other complex environmental stimuli. Consider visual stimuli, for example, much more complex. So if autistic children, autistic people, have difficulty processing environmental signals rapidly, it may explain why they, in fact, appear as they appear to us, somewhat different from normal people, because they aren't processing things or keeping up as rapidly. Now, eventually, for us to be able to reduce that to some, say, therapy, you've got to know more about the intrinsic chemicals that are causing that signal to be slower, and that isn't addressed in this study, but it is giving us an interesting look into the physiology and pathophysiology of autistic problems.
An interesting look from a piece of equipment, a piece of hardware that is very expensive. Now, I understand this is only one application for this, but if you just look at the price tag on just getting the machine in there in the first place, that's $3 to $5 million. Dr. Tashjian, in today's world, with the economy that we're now facing, do you think that the big price tags on this hardware, is this going to slow research and development in your field?
I think anything that costs that much money is going to have to be looked at closely. And in this economy, we're going to look at it more closely than we might otherwise do. But what it might do is it might focus this research into centers that really will have the ability then to do the research. And one of the real nice things about this study is that maybe this is a way that we can differentiate. The various spectra of autism may be quite large, and we may be actually able to focus on smaller areas and then use treatment that would work for some groups, but not waste that treatment on other groups. And the thing that's exciting to me about this study is it really gives us a way of maybe measuring autism or measuring different individuals with this disease and really trying to separate out the spectra into areas where we might focus better treatment on.
So even though this is, as it say, pricey equipment, we have a huge problem. Autism, I think it's generally agreed. You're seeing the numbers go up there. It's not really understood why. But I suppose one could say that anything that helps on unlock the mysteries may, right, in fact, be worth the price.
Absolutely.
Well, I believe that you also want to see the centers that now have the technology, as Dr. Tashjian pointed out, have them actually pursue this further, use that technology to help us understand the disease better. Then we can understand if it's really worthwhile for us to invest more funds.
So there are only 2 children's hospitals that have this, but your hospital,
St. Louis University Hospital has it, and we have the Cardinal Glennon Children's Hospital, stuck right on to the St. Louis University Hospital. So I think we are in position to pursue these studies, and I hope we will.
Mm-hmm. Well, so again, lots of news here on Monday at RSNA. Join us again tomorrow at RSNA in Chicago. I'm Peggy Peck, MedPage Today.